Hello, everyone. Welcome to Feedstuffs 365. I'm Sarah Muirhead. There's new research out that shows that if more U.S. food companies require feed for their livestock and poultry to be free from genetically modified ingredients, then greenhouse gas emissions on farms could rise. In addition, grain elevator and feed mill product handling and production requirements would be greater, and the price of meat, milk, and eggs at the retail level could increase. Joining us with the details of this just released research is Lara Moody, IFEEDER Executive Director. For those of you not in the know, IFEEDER is short for Institute for Feed Education and Research. Welcome, Lara. Great to have you with us today.
Hey, Sarah. Thanks for having me on to talk about this really interesting study today.
I'm just going to turn the stage over to you. I know you've got some slides that you're going to walk us through and show us some of the results of this work.
Great. Well, as you indicated, we're going to take a look at the impact of non-GM feed for the U.S. feed industry. And in particular, what made us interested in this study was seeing the kind of slowly expanding growth of egg and meat and milk products on the consumer kind of market shelf that were GM free. And of course, if you're going to have GM-free products in the animal space, that means the animals need to be consuming non-GM feed products. And so from an industry standpoint, the industry needs to understand what the implications are for that potentially increasing feed space of non-GM feed. And so that's what this study started to take a look at. As the research and education foundation for the American Feed Industry Association, IFEEDER pursued this effort to help us along our mission, which is advancing the understanding and trust in a sustainable feed and pet food supply chain through timely research and education. When we do projects like this, we seek funding partners, and in this case, we partnered with DMI, MFA, the National Corn Growers, U.S. Poultry and Egg, as well as a few other contributors. The report was prepared for us by the lead researcher, Erin Bowers, and her team at Iowa State University, along with representatives from Decision Innovation Solutions. And so the report that I'm going to share with you today has a variety of resource materials available for it. You see the reference on the lower right side of the screen there. There's a web page for the report, IFEEDER, available on ifeeder.org. And if some of the things that I say today are of interest to you, you can go take a look at the 150-page full report, or you can look at the executive summary or other collateral materials that are there available for our audiences and stakeholders to use. So again, we wanted to explore the differences both on the farm and in the manufacturing and handling systems that would occur between using genetically modified and non-genetically modified grain in the production and handling processes. And so we wanted to understand from the farm's perspective what the environmental and cost were, and we did that by examining land use, energy use, and input use on the farm. But we also wanted to understand what the implications would be for the grain elevator and the feed mill relative to operational changes that might need to take place or capital investments that might need to occur, and then what the impact of those investments and changes would be on the cost of feed as well as the cost to the consumer. So some of the key findings that I'm going to start with here, just to give you a little bit of background into where we are today with GM seed use on the farm. And so in the 1990s, as genetically modified traits started becoming available, we started to see this slow increase in adoption rate. For corn today, we are at about 92% of all seed corn grown today is using GM trait technology. And there are several reasons for that. The biggest reason is really the increase in yields. So the researchers in this study looked at literature that was available and found data that could show yield increases or yield advantages were around 6 to 25% when you were looking at similar traits across non-GM seed production. Soybean, also around 94% production is produced with GM seed traits right now. Again, they have a similar, have a yield advantage, not as significant as corn, but still a yield advantage. From a monetary standpoint, the cost of GM seeds are generally higher, but the inputs and the operations on the farm that are tied to them generally have reduced cost over non-GM seed technologies. And so for a farmer today to make a decision to go back to using non-GM traits, there would have to be a pretty significant premium in place for that to occur. So that's one thing that's of interest as we look at the potential to even have grain available that we could use in the feed space. There would need to be some significant changes in production to be able to produce more non-GM feed than we do today. When we start to look at some of the environmental benefits, the first place that the researchers looked was grassy habitat conversion. And so grassy habitat conversion, kind of in sustainability speak, if you will, is often referenced as land sparing. Sometimes we think about land sparing when we're thinking about a forest that's being turned into crop production space, like maybe, for example, in Brazil. But here in the US, land sparing is a little bit more looking at grassy habitat conversion. So they looked at a 13-state Midwest region to do this assessment. And just using the GM traits that we have available, so just current situation, from 2007 to 2016, we saw about a 14 million acre increase, or 14 million acres of grassy habitat converted to crop production within the US. Now, if we then start considering what some of those equivalent land conversions would be to be able to keep up with equivalent production because of that yield advantage that GM seed has over non-GM production, we in some cases could end up doubling the amount of grassy habitat conversion that is taking place if we were to convert over to non-GM production over GM production. So there is a significant, potential significant impact on grassy habitat conversion if we convert back to using non-GM seed. As you referenced, Sarah, in your opening comments, the researchers also looked at greenhouse gas emissions. Now, they weren't looking at some of the current data that's already available, knowing that we have current literature that shows that when we look at no-till or minimum till systems, that we have some reduced greenhouse, or we have, reduced greenhouse gas emissions, but also carbon sequestration and other things that take place because of that reduced tillage. So they didn't explore that element. What they did look at was, given the additional operations that would be considered for non-GM seed technologies, specifically with corn, what additional fuel use was tied to those additional operations. And so what they looked at was GM corn versus non-GM corn from a fuel use standpoint, and no-till corn versus conventional till corn from a fuel use standpoint. And to do that, they utilized University of Nebraska 2020 season crop production budgets. And what they found was that, just purely tied to fuel combustion, that GM emitted about 21% less CO2 than non-GM. And for no-till, that was about 41% less than conventional till corn. Then they said, well, what would it look like if we were to increase non-GM corn production annually? And from a greenhouse gas emission standpoint, they estimated that there would be a 7% increase in greenhouse gas emissions tied to that 5% increase in non-GM corn use. And amazingly to me, that is the equivalent of putting about 42,000 cars back on the road just from increasing non-GM corn production by about 5%. So that was a pretty staggering statistic to me. When we move kind of from the environmental and cost implications and start looking at handling relative to movement of the product from the farm to the grain elevator to the feed mill. Starting with on the farm, of course, there are some costs to handling. Everything in this element of the report or research was looking at segregation requirements that were needed to maintain kind of the purity of non-GM crops from GM handled crops. And so on the farm, that meant looking at isolation distances between field to ensure that we had no kind of cross-pollination occurring. And then also the special equipment preparation that was needed for handling seed at planting or harvesting. And then, of course, the storage requirements. And so on the farm, that equated to about a 5 cents per bushel increase for handling non-GM corn and soy. Once we get to the grain elevator, they looked at different scales of elevators. So elevators that were handling anything from 500,000 bushels to 1.5 million bushels a year. And they looked at a few different types of segregation that could occur. So one was temporal segregation, which would mean the grain elevator on specific days of the week would handle one type of material versus the other. Spatial might mean that you have two lines and you would handle GM product on one line and non-GM product on another line. Or the other way they looked at handling segregation was just to have a dedicated facility that only handled non-GM product. They looked at a variety of costs that were tied to different operations or some capital investment that would be needed to put in place if you were going to do some of that spatial or dedicated handling. And essentially at the grain elevator, they found that the cost per bushel would increase anything from 5 cents to 9 cents for corn and soy. Now, where it gets more complex is looking at the segregation requirements within the feed mill. Same thing. They looked at different scales of feed mills, anything from 10,000 to 50,000 tons per year of product. Again, looking at the similar types of segregation, both temporal, spatial, or dedicated lines. Generally, they looked at some of the same operation and capital investments with some of the additional elements that you would find at a feed mill. And this is where really the cost started to go up. And so within the feed mill, they found that for swine, broiler, and layer feed, the cost could go up anything from $4 to $9 per ton. Now, that was more significant than the beef and the dairy feed. For beef and dairy feed, the cost per ton went up from about 44 cents to $4 a ton. The main difference being that for the swine layer and broiler feed, the cost was greater because a significant piece of their diet, really more of their diet, is linked to products that move through the feed mill than what moves through for beef and dairy cattle. The final thing that the researchers looked at was the actual ability to achieve what is termed adventitious presence. And really what that is ensuring that you have, the right level of purity of product, the right level of purity for the non-GM product. In other words, that you don't have commingling of genetically modified product within that. The different levels are linked to the 9% level is based on levels required in the EU. 5% is a level that they look at here within the US, but they looked at the different tolerances and how we might be able to achieve those. Essentially, they looked at several different types of feed mills, from single species, single processing lines, to multi-species, multiple processing lines. In all cases, the 5% and even the 0.9% were achievable. However, there were a very complex set of procedures and operations that were required to achieve that, which those additional complex operations is really what would make it challenging for a feed mill to be able to implement those. In some cases, just from some of the individuals that I've spoken to or heard feedback from relative to this component, they said it would be darn near impossible to make some of those happen within many of our feed mill operations, and that really a dedicated line might be the only way to make that occur. I should have said and then one more element that they did look at. So the previous wasn't the final element, but they took information from that study and converted it over to what those ton of feed costs per species would look like if you turned that into the increased protein cost. And so again, similar trends to what we saw in increased feed cost. Essentially, we have the potential to increase the protein cost of egg, broiler, and pork production anywhere from 13 to 17%. And then likewise, also a protein increase for dairy and beef, just not as significant, again, because not as much of their diet is tied to products that are produced through the feed mill. So the key takeaways from the project, I think, are, number one, big takeaway is that we really need to be able to have access to the technologies that are out there if we want to achieve the sustainability goals that society and consumer product goods companies and others are putting on agriculture and the food supply chain. From the farm's perspective, there is definitely a yield advantage that is driving environmental and economic benefits on the farm. And until we have similar yields in non-GM, it's going to be really challenging to get farmers to move back to using non-GM technology. At the feed mill, there are definitely capital and operating costs. Segregation is possible, but it's going to be really challenging to do without just sole dedication of a facility. From a consumer standpoint, there is likely a potential increase in protein that will occur. And then from a food producer standpoint, one of the things we want to be able to do with this study is show kind of what non-GM implications are. So as food companies, potentially pursue expanding their shelf space of non-GM products, what are those implications linked to feed? And then what do those implications have if they've got a climate target set, but we show that this has the potential to increase their carbon footprint? How does that factor into their path to, achieving that climate target? So we have many ways that we want to use the results from this study, and we're just starting to do their outreach. And Sarah, really appreciate the opportunity here to talk about those findings.
Thank you so much, Laura. It looks like you guys have really done an extensive amount of research all the way from, from the field to the farm, all the way to the consumer. So that's very interesting to see all those different components. Now, you did mention that it would be possible for a feed mill to handle both the GM and the non-GM grain, but you seem to indicate it would be a little bit difficult. Would it also set them up just from a regulatory standpoint or an oversight standpoint to a lot more just a lot more hoops and things they have to worry about?
Well, so there certainly would be additional oversight relative to being able to certify that you are handling and keeping the purity requirements for non-GM feed. The challenges in that space began to be linked to things like keeping elements of the facility clean, or if you're moving the same product through one line, is it sufficient just to run that line empty for a while, or do you have to move product and then bypass that product, or how long do you have to do that? They didn't explore those elements within the study, but those are the types of complexities. In addition, something that it's one thing to say you're going to do the testing that's required to determine if you have that purity of product coming in. But then once you do that testing, you have to have the additional people to do the testing. You have to have the place to hold the product while you're waiting for the test results, which aren't always immediate. There are just many layers of complexity that come in on top of maybe the capital investments that are required.
Right. It's like when you're dealing with the organic grain, you have to make sure it's organic when it's coming through your facility, or, there goes all of that what some folks would say the benefit of being in that market.
That's right.
So do consumers, did you take a look at all consumers really care about GM grain? I mean, I've seen some research lately showing that it's actually becoming a lot more accepting. Consumers are saying it's okay. I'm understanding it better and I'm accepting of it. Were you able to pick up on any of that, or have you followed any of that?
This study did not assess the consumer's reaction or the consumer's, consideration for the use of GM. I think the most telling thing to me remains the misunderstanding that folks have in the space. I was speaking to a friend of mine about the different of what I was doing this week, which required me to be on camera or doing a series of interviews and webinars talking about this study. And I asked her if she, kind of understood the scope of products out there or crops that we have that are GM. And she was like, well, I always buy non-GM bread. And I'm like, there's no wheat that's genetically modified. And she, and so there's a misunderstanding, I think, of folks what actually the space is or what it entails. And to me, that's a really challenging element. And then as I further talked to her, and asking her if she did in fact have a problem with consuming genetically modified, product, was the environment also important to her? And she said, of course. And so when I talked to her about, the potential, what the potential means, right, for raising non-GM crop and what the environmental outcome is, she had no idea that was, even an impact. She just assumed that it was non-GM, organic, and therefore all good. And so I think, it gets back to, as we do have people being more accepting of GM as a term, also ensuring that they are informed on what it actually means. Because, you come across an educated person and you expect they do, but they don't.
Right, exactly. They just hear the stories that are out there. Right. Any sense on where the feed industry is in terms of trying to go non-GM? Are there companies out there that are really active in this space, or are they really evaluating it? Do you have any sense on that?
I don't believe that, I should say I don't have a good sense on where the feed industry is from a production standpoint, volume wise, except to say that certainly it's occurring because there is product that is being fed, from a non-GM, because clearly there are products being produced from non-GM. But again, that wasn't a part of the study. We haven't looked at where the feed industry is. Our real intention was understanding where the food industry potentially wants to go. The feed industry needs this type of information to be able to make decisions on whether they want to do that or not. Just talking to one of the researchers is a crop producer himself. And he said, when I was doing the study, I thought, well, I'm going to try and grow some non-GM because maybe it'll help save me on some of my input cost. And he said he did. And the challenge that he had was ultimately he ended up with lower yields, but lower input costs. So he was okay with that. But when he tried to find a place to sell it where he could get the premium, he was going to have to transport it too far because there was no feed mill in his vicinity that would take the material at the premium that he wanted. So he ended up selling this product along with the rest of his GM corn all in the same load because it was just too expensive for him to get it to where he wanted it. So, I think the thing to think about, I was talking to a farmer group, a producer group the other day, right? And in the livestock space, if you're a livestock farmer and you're thinking about, oh, maybe I can get some premium by raising non-GM, animals for production, well, then you kind of got to think through where you're going to get that feed from, because logistically it may not work. The cost may be too great to get the product you need because there are not enough, feed mills handling that product, which I think is probably the case right now.
It's kind of following that whole chain back before you make those decisions.
Right.
So next steps, you mentioned that you're rolling out this report and talking about it and getting in front of various groups. What else is planned?
Yeah, so we've had great conversations with some of the feed industry members that have interest in this space, folks that, beyond just talking, it's really, lovely to be on here with you all, but oftentimes we just talk to ourselves and we need to go beyond talking to ourselves. So, for example, in a couple of weeks, I'll be talking at the U.S. Roundtable for Sustainable Beef, where I'll bring up some of these topics. I'm going to be talking to the Distillers Grains Technology Association relative to, this element and other sustainability pieces. But we also have some feed industry members that are planning to open the doors for us to some of the consumer product goods companies that are, looking at the non-GM space, because I think the real opportunity here is, as those consumer product goods companies are setting their big climate targets or setting their goals and starting to think through their pathways of how they're going to reach these greenhouse gas, reductions or carbon footprints in their supply chain in the next 10 to 15 years. Well, that's a little crosswise with what they may want to do in the non-GM space, and they need to understand those implications so that they can make good decisions. And so we're looking for ways to be able to do that outreach.
Very good. Lara Moody, Executive Director of IFEEDER. Thank you so much for joining us
Yeah,
today,
thanks so
Laura.
much for having me on, Sarah.
Thank you all for joining us as well. We've got another program coming up tomorrow. Dr. Steve Pullman is going to talk about barrows and gilts, so please tune in for that. Until then, for Feedstuffs 365, I'm Sarah Muirhead.